Hi everyone, this is lecture 19 in analog circuits. In this lecture, I will cover these two topics, that is voltage doubler, voltage tripler and quadrupler. In the previous lecture, we have discussed about the peak detector, that is using a capacitor and a diode. And if I take the voltage across the capacitor, so there is a diode here and there is a capacitor here, and if I apply a input signal, AC signal, which is having the peak of Vm2 minus Vm, then the output voltage or voltage across the capacitor is nothing but the peak of the input signal. So the output we will get as something like this, right? The capacitor will charge it to the maximum peak, that is Vm, and it will be stays for infinite time because the diode will be off for all other conditions. So that is, it is detecting the peak of the input signal, right? So in this voltage doubler, so the output voltage will be twice of the input peak. So that's why it is called voltage doubler. In this voltage tripler, we will get the V out as thrice of the Vm. That's why it is called voltage tripler. In this, we will get the V out as 4 times of Vm. So that's why it is called voltage quadrupler. Right, so one by one we will see. First we will see the voltage doubler. So this is the voltage doubler circuit. So we have to use two capacitors to make the voltage double, right? Now if you recall, if I remove this circuit, so this is nothing but the clamper only. Each type of clamper, see the arrow of the diode, so it is going up, so it will give the positive clamper, right? Then if I add this peak detector, then we'll get the output as twice of the input peak, right? Now I can give you a rough idea how this circuit will work. So if I remove this part, so it is simply acting like a positive clamper. So something like this. This is the capacitor C1. This is the D1. This one. Suppose if I find the voltage, output voltage here, V out 1, and if I am giving the start from the negative half cycle and so on, so what is the output waveform we will get? So this is from minus Vm to plus Vm. So if you recall from the clamper operation, if I give the negative half cycle, so first from 0 to minus Vm, the diode D1 will be on, so minus plus, so the diode D1 means on, means it is a short circuit, so the capacitor will charge like this. So that means plus minus the capacitor voltage. So here Vm, so plus Vm minus Vc1 is equal to 0. So what is Vc1? Vm, right? If I give the polarity as like this, plus minus Vc1, we will get minus Vm. So this is the Vc1. So when the next positive half cycle comes from 0 to Vm, the diode will be off. So that means the circuit will become like this, plus minus Vm, and I am applying the plus minus Vm, positive half cycle. The diode D is off. Now what is V out? So V out is equal to minus Vm plus V out is equal to 0. So what is V out? V out is equal to 2Vm. So if I draw the output waveform, what we will get? So we will get the DC voltage as Vm, and we can get the maximum peak as 2 Vm. So approximately we can get the waveform as something like this, right? And so on. Now what is the maximum peak? 2 Vm, right? Now if I add a peak detector for this signal, so if I add a peak detector for this signal, so the diode is here D2 and the capacitor C2. Now tell me what can be the output. So very simple, this is a peak detector, so it will detect the peak of the input signal. So the output waveform will be something like this we will get. So this is the V out. So it will detect the peak of the input signal. So what is the peak? So 2 Vm. As the capacitor is charged to 2 Vm, right? So this is the 2 Vm. So the maximum is, the input maximum is 2 Vm. So the moment it is charged to 2 Vm, the diode will be off. That means it will be open circuit. then the capacitor stores their 2Vm up to infinite time. So we'll get the output as like this, right? So this is a rough idea how this voltage doubler works, but practically the working scenario is somewhat different. So that we will see step by step, right? So again I have to take the circuit. So what I will do is, always remember, if the first diode D1 is like this, so always try to start from the negative half cycle, right? If the diode is like this, then we can start from the positive half cycle. So that's why I'll start from the negative half cycle. So the input I have to take something like this. So this is the V in. So maximum I can take negative side minus Vm, positive side Vm. Now first we'll see. So when I apply this negative half cycle up to minus Vm, so what will happen to the diode D1 and diode D2? So I'm applying the negative values. So that means I have to apply something like this, minus plus. So initially the capacitor is uncharged, right? So when it is uncharged, so we can say directly whatever we are applying, that will be appear across the diode D1. So that means minus is connected to the N-type semiconductor, positive terminal is connected to the P-type semiconductor. So the diode D1 will be on. So up to here the diode D1 will be on, and we can apply some voltage levels, then we can verify. Suppose minus plus means suppose minus 1 volt. So minus 1 volt, we know the theory, right? Open circuit method. So that means VK1 will be minus 1. VA is connected to 0. So VA1 will be 0. Which one is higher? Anode voltage is higher. So the diode D1 is on. So the diode D1 is on. So minus 1, minus 2, minus 3, minus 4 up to minus 5 or minus Vm. But what happens here? So initially the capacitor is uncharged. So whatever this voltage is here, so this will appear here. That means VK2 is 0. But VA2 is connected to this one, so whatever VK1, VA2 will be same. So VA2 will be minus 1. Now which one is higher? Cathode voltage is higher. So the diode D2 will be off. So from 0 to minus Vm, the diode D1 on, D2 off. Then what happens to the capacitor C1? So the equivalent circuit will be like this. C1. So maximum I am applying minus plus Vm, and this is a short circuit, and this will be a open circuit, and this is the capacitor C2. So there is no charging path for the capacitor C2. So here Vout will be 0 or Vc2 will be 0. But what happens to the capacitor C1? So what is the time constant in this loop? 0. So it will quickly charges to, or depending on how this input is varying, the capacitor also charges depending on that. Now how it will charge? See the diode. So diode is like this. Current is flowing from P to N. So the capacitor will charge like this. That means this is the plus, this is the minus. So this is the Vc1. Now tell me what is the Vc1? Very simple. Apply KVL. So plus Vc1 minus Vm is equal to 0. So what is Vc1? Vm, right? So this is the, see here, from 0 to minus Vm, right? Now what happens when we increase the input signal from minus Vm to plus Vm, right? For that I have to take some voltage levels, then it will be clear. So what I will do is, I am taking minus plus, suppose 2 volts, and take it as Vm is equal to 5 volts. So this capacitor is charged to minus plus 5 volts, and this is the diode D1, and this is the diode D2. Remember, this is not the analysis, this is knowing which diode will be on, which diode will be off. Now see, if I find the voltage here, so I will take it as VK1. So to find that one, so anyway this is 0 volt. So apply KVL, we will get plus 2 minus 5 plus VK1 is equal to 0. So what is VK1? 2 minus 5 minus 3, so it will be 3 volts. So VK1 of the diode D1 is 3 volt, but VA1 is 0 volts. So VA1 is 0 volts. Which one is higher? Cathode voltage is higher. So that means the diode D1 will be off from minus Vm to plus Vm, right? So minus Vm to plus Vm, the diode D1 will be off. But what happens to the diode D2? Yes, VK1 we got 3 volts. That means VA2 is 3 volts. VK2 is, the capacitor is initially uncharged, so 0 volts. So VA2 is greater than VK2. The diode D2 will be on. Then the equivalent circuit will be like this. So this is Vn. So I can apply maximum positive value as Vm. And the capacitor is C1 is charged to how much voltage? Minus plus Vm. And the diode D1 will be off. And the D2 will be on, short circuit, and the capacitor is C2. Now I need V out, right? And to find that one, now I can apply the KVL, then we will get something like this. So minus Vm plus V out is equal to 0. So what is V out? 2 times of Vm. So that is the output voltage is the twice of the input peak, right? So this is voltage doubler circuit. When you see any textbook, the explanation will be like this only. So that is, for the negative half cycle, the capacitor C1 is charged to Vm, right? Or we can say minus Vm. And for the next positive half cycle, the V out will be 2 times of Vm, etc. Right? But practically it will not happen like this. Reason is, for that we will need one more concept, that is, suppose I am having some voltage V, and if there is two capacitors are in series, something like this, then if I want to find what is the voltage across the capacitor C1 and voltage across the capacitor C2, then how we will find? We will find using the voltage division rule, right? For that, what I can do is I can make it as this as Z1, this as Z2, right? Then VC2 will be Z2 into main voltage by the total impedance Z1 plus Z2. But what is Z2? This is, we can say, 1 by J omega C2. Similarly Z1, 1 by J omega C1. So this will become 1 by J omega C2 into V by 1 by J omega C1 plus 1 by J omega C2. If I cancel out J omega, this will be V by C2 by 1 by C1 plus 1 by C2. So this will be something like this. So VC2 will be V by C2 into C1 C2 by C1 plus C2. So what is this? V into C1 by C1 plus C2. This is the VC2. So that means this voltage will be divided between the capacitor C1 and capacitor C2. So that means if I take C1 is equal to C2, C1 is equal to C2, what happens? VC2 will be V into C by 2C. So VC2 will be V by 2 and VC1 also V by 2. So equally divided. So that concept we have to apply here. Now if I see, this is the capacitor C1, it is already charged to minus plus Vm, and this is a capacitor C2. Now it is charging through this path, right? Now whenever it is charging, so there is a capacitor C1 also. Initially this is having some Vm, minus plus Vm, right? Now it is try to discharge or it try to charge also, right? So what will happen? We'll see. So if we see here, the input is changing from minus Vm to plus Vm. Now can I say what is the overall change here? 2 Vm. Yes. So now the circuit will be something like this. If I draw very clear, this is C1, okay, minus plus Vm. So this is, I can take it as total change is 2 times of Vm, and this is the C2. So if I find this V out, right? So and we have to assume this condition C1 is equal to C2, which is equal to C. So that means V out will be 2 times of Vm into C by 2C. So 2 cancel, C cancel, so V out will be Vm. So that means the capacitor C2 charges up to Vm only. So if I see the waveform, see, so from here to here the diode D2 will be off, that means capacitor C2 will be 0. From minus Vm to plus Vm, as the input is varying, the diode D2 is on, the capacitor is charging. So how much it can charge? It will charge from 0 to Vm only, right? So if I draw the waveform, something like this. So here, so up to this condition, D1 on, D2 off, right? So that means D2 off means VC2 will be 0, which is also equal to V out, right? Now as input is changing from minus Vm to plus Vm, so from these conditions, D1 off, D2 on, and V out is Vm only. So the capacitor is charging, and it will reach it to Vm, right? Then if I apply the, suppose from Vm to, if the input is varying from again Vm to 0 and 0 to minus Vm and come back to 0, etc., what will happen? And remember, the capacitor C2 will not charge to 2 Vm for the first cycle, right? It may take few cycles, maybe 3, 4, so on. I will show you simulation results, then it will be more clear, right? Up to now VC2, this is the curve for V out, so it is charged to Vm only. So we need some more time to charge the capacitor C2. How? Now again I have to draw the circuit. Now tell me what happens to the capacitance voltage that is already charged to minus plus V. So it is already charged to minus plus Vm. Now as C1 is equal to C2 is equal to C, so V out we got Vm. That means across this capacitor C1 also there will be Vm, then only the KVL will be satisfied. See, this is the Vm, this is the minus 2Vm plus Vm will be 0. So that means this is the plus Vm minus Vm. The capacitor voltage will be 0 after this cycle, right? So this is the diode D1, this is the diode D2, and the capacitor is charged to how much? Vm. So here I can say simply 0 volts, right? So this is the Vn. So this is the circuit diagram because C2 is charged to Vm. Now we are starting from again Vm to 0 and 0 to minus Vm. What will happen? We will see. Suppose, okay, I will consider some voltage levels, then it will be clear actually. Suppose if I consider 4 volts, suppose plus minus 4 volts, and I am considering Vm is equal to 5 volts. So this is the 5 volts. Okay, so this is not capacitor, diode, right? This is the 5 volts, Vm is 5 volts, so it is charged to 5 volts, and I am applying 4 volts only. This is initially uncharged, so 4 volts will be appear here. So this is the 4, this is just 0, so D1 is off. What happens to this fellow, the diode D2? This is 5 volts, this is 4 volts, this is also will be off. So that means from 5 to 0, from 5 to 0 here, or the next cycle, that is from 5 to 0, D1 and D2 both are off, right? When both are off, so it will be like this: open circuit, open circuit, and this is the C2 which is have already Vm. So the capacitor C2 is not discharging, so it is storing that voltage continuously. So that means from here to here, right, the diode D2 will be off, so it will be maintained constant and so on. Up to minus 5 or minus Vm, the diode D2 will be off only, right? Yeah, it should be constant, okay, constant. So we reach it to 0, right? Up to here also the diode D2 will be off. I'll tell you later. Just for to draw the output waveform, I have to draw up to here. So this is the input which is varying from 5 to 0, right? Then the moment it is less than this 0, when Vin is less than 0, or we can say 0 to minus Vm. So as Vin is varying from 0 to minus Vm, so what happens to the diode D1? Yes, it will be on. Why? Suppose this is the minus 1 volt, this is 0 volts, it will be on. So from 0 to minus Vm, so I can get maximum minus Vm. So this is the capacitor C1 and this will be on. What happens to diode D2? Will be off. Still it is the capacitor voltage C2 is still Vm, right? And now see, again the capacitor C1 will charge it like this. Now you can ask, what happens to the diode D2, right? Why it is off still? Very simple. This is the 5 volt and I am applying the negative values here, so it will be still off only. Now tell me what is VC1? Again it is Vm. So minus Vm plus VC1. So this is the VC1 is equal to 0. So VC1 will be Vm. Right? Again the capacitor is charged to Vm. Right? Clear? Now what happens again when Vn is varying from minus Vm to 0 volt? So this is plus minus Vm. Now I am changing from minus Vm to 0. So the diode D1 will be off. Very simple. Again we have already seen in the first cycle, right? But what happens to the diode D2? So this is the 5 volt, right? And tell me what is this voltage? VA2. This is the VK2. Suppose if I apply 0, right? Plus minus 0. So minus 0 minus Vm plus VA2 is equal to 0. So what is VA2? VA2 is Vm only. That means 5 volts. So 5 and 5. Will the diode will be on? No. VA2 should be greater than 5 volt. So from minus Vm to 0, the diode D2 will be off only, right? So from minus Vm to 0, the diode D2 will be off, as well as D1 is also off. I hope it is clear. If it is not clear, what you can do is apply some numerical values, then it will be very simple, right? Minus Vm to 0, you can apply any middle value, minus 2 volts. So here minus plus 2 volts, right? So we can apply like this, minus plus 2 volts. This is minus plus 5 volts. Apply KVL, you will get plus 2 minus 5 plus VA2 equal to 0. So what is VA2? 3 volts. But I need at least greater than 5 volts. So that's why the diode D2 will be still off. And anyway this fellow will be off. Diode D1. That is, so this is the VK1, VA1. So VA1 is connected to 0. So VA1 will be 0. And VK1 will be VA2, which is equal to 3 volts. Which one is greater? Cathode voltage. So the diode D1 will be off, right? So if I see this waveform, so that's why I have drawn up to here. So from minus Vm to 0 also, the capacitor voltage C2 will be same because there is no path. So up to this value, the Vout follows that Vm only, right? Now what happens when we apply from 0 to again Vm, right? So I can say like this, from 5 to 0, D1 and D2 are off. So D1, D2 off. So here D1 on, D2 off. From minus Vm to 0, again D1 and D2 both are off. Now we'll see from 0 to Vm. So this is charged to Vm, diode D1, D2, and this capacitor C2 which is charged to Vm, right? Now I'm increasing this Vn from 0 to Vm. So if I take numerical value, it will be clear. So I'm taking suppose 1 volt. So plus minus 1 volt. So I have to take Vm as some value. So I'm taking as 5 volts. So minus plus 5 volts. Then this is the VA2, or we can say VK1. Now apply KVL, minus 1 minus 5 plus VA2 is equal to 0. So what is VA2? 6 volts, which is also equal to VK1, 6 volts. But what is VA1? See, it will be connected to ground. So VA1 will be 0. Now see, VA1 is 0, VK1 is 6 volts. That means diode D1 will be off because cathode voltage is larger. But what happens to the diode D2? VA2 is 6 volts we got, and VK2 is charged to Vm, which is 5 volts. Now which one is greater? VA2 is the greater. So that means what happens to the diode D2? On. I think it is clear. Then once it is on, the scenario will be like this: minus plus Vm C1, and Vin is varying from 0 to Vm, so I can take it as plus minus Vm maximum. And this is the C2 which is already having Vm, right? Now tell me what can be the new value Vout. Very simple. Again, two capacitors are in series, so whatever Vm, it will be divided equally if C1 is equal to C2. So now the capacitor will charge it to from Vm to only Vm by 2, because this is the Vm, this is the C1 and C2 are in series, and I am assuming both are equal, so it will divided equally. So that means the new Vc1 will be, previously it was minus Vm, now it will be plus Vm by 2. Now Vc2 is previously Vm, now it will be charged to Vm by 2. The total will be 3 Vm by 2. So here minus Vm by 2, right? Now how to draw the waveform? So from 0 to Vm, the capacitor C2 is charging. How much it will charge? Vm by 2 only. Previously Vm, now it will charge it to Vm by 2. Now we can guess what happens to other cycles. Now it will charge it to Vm by 4, one more cycle Vm by 8, and so on, right? So that you can do on your own. So I will draw final output waveform. So this is the input waveform. So up to here the Vout was 0, right? And from here, from minus 5 or minus Vm to plus Vm, the capacitor C2 is charging, and it is charged to Vm. Then it will maintain constant up to this point. Then it will charge it how much? This is the Vm, so this will be Vm by 2. Now we can guess easily from where the capacitor C2 will charge again. If you compare here, see the capacitor C2 was charging from here, right? Actually it should start from here, but it is taking some time. Similarly, it should start from here, but it will take some time. So up to this will be maintained. Then it will charge again. How much? Very small. This time maybe Vm by 4, and so on. So it will take some more time compared to the previous one. So again it will charge smaller, that is Vm by 8, and so on. Finally it will reach to 2 Vm, right? Maybe 4-5 cycles, right? So this is actually happens in voltage doubler circuit, right? I think it is clear. If not clear, go step by step, then you can get easily. Now I will show you some simulation results for this voltage doubler circuit. Now see here. So this is the voltage doubler circuit, right? So this is the, one second. So diode D1, D2, capacitor C1 and C2 I am taken both are equal, 10 microfarad, 10 microfarad, right? Now if I do the simulation, so this is the input waveform which is started from 0 to minus Vm, then plus Vm, and if I see the output across the capacitor C2, now see the variations. See here, so it will charge it to Vm. So there is a difference because we have to consider the practical diode, so there may be some difference of 0.7 volt. Then see here, it is charging from almost 0 to Vm. Again see, it is previously it was charging from here, this point, now it may charge from this point, and see again it may charge here, very small, and finally we'll get the double the voltage of the input peak, right? So this is the simulation results of the voltage doubler circuit, right? We can have the load resistance, etc. So when we connect a load resistance, the capacitor C2 try to discharge through that resistance depending on the time constant. When the time constant is very large, the voltage across this capacitor C2 will be maintained constant only. That we know already. We have done for the peak detector in the previous lecture, right? So this is the waveform we will get for this circuit. So this is voltage doubler, but what is the Vout we are getting? We are getting positive 2 Vm, but we can get negative 2 Vm also. That we will see. That is the second circuit. So that means first what we have to do, we have to place negative clamper, then negative peak detector, right? So this is the circuit diagram. So here we just flip the diodes compared to the previous circuit. So this was the previous circuit which was giving 2 Vm. If we just flip this diode as well as this one, then it will give Vout as minus 2 Vm. So here we will get Vout as minus 2 Vm, right? So what is the procedure? Very simple. So if we remove this circuit, so this is a simple negative clamper. Then if I connect this circuit, so it will detect the peak. So the procedure, I will go very simple procedure, that is from 0 to Vm, the diode D1 will be on. So from Vn greater than 0 and it is from 0 to Vm, the diode D1 on, D2 off. That we can say directly. So 0 to Vm, so initially the capacitor is uncharged, so whatever is there that will be appear across the D1. So this is the positive, this is the negative, forward back. This is the positive, so positive is connected to the N-type semiconductor, so the diode D2 will be off. So when it is off, the circuit will be like this: C1 short circuit, open circuit, C2. So how much I applied? Maximum Vm. So the capacitor charges like this, because see the diode terminals P2N, the current will flow. So this is the, so what is the voltage? Plus minus Vc1. So this is the Vc1. Apply KVL, we will get minus Vm plus Vc1 equal to 0. So what is Vc1? Again Vm only. Now tell me what is Vc2, which is also equal to Vout? 0, because it is not charged, ground over, right? So this is up to from 0 to Vm. So what happens from Vm to minus Vm? Vm to minus Vm. So if Vn is changing from minus Vm to, plus Vm to minus Vm. So here, so maximum I can apply Vm, and this is already charged to plus minus Vm C1. So we have to see which diode will be on, which diode will be off. So for that I'll go like this. So plus minus 5 volts, suppose this is minus plus, suppose if I take 4 volts, minus plus, and this is the diode. So this is the, I can take VA1, and this is the diode D2, I can take VK2. So apply KVL, plus 4 plus 4 plus 5 plus VA1 equal to 0. So VA1 will be minus 9 volt. That's it. So VA1, so this is the VK1, which is 0. VA1 is negative, so D1 off. But what happens to D2? So VK2 is minus 9 volt and VA2 is connected to ground. So which one is higher? VA2 is higher. That means diode D2 will be on. So off, just opposite of the previous cycle, right? So it is on, and this is the capacitor C2. Now see the diode polarities. It is looking like this. So the current will flow from P to N. So the capacitor will charge something like this. So if I find this is as some V out, and if I apply KVL, so what I will get? Maximum minus V out minus VM minus VM is equal to 0. So what will be the V out? Minus 2 VM. So that's why it is called voltage doubler. But practically it will not happen like this, as we have discussed for the V out is equal to 2 VM. That is a, we can say, positive doubler. So same thing will happen like this. So it will charge minus VM, then minus VM by 2, minus VM by 4, minus VM by 8, minus VM by 16, and so on. Finally we will get minus 2 VM, right? So I hope it is clear. Now you may ask doubt, as this voltage doubler is converting this AC to DC voltage, yes or no? So my VM minus VM. So why we are not using this voltage doubler as AC to DC converters, right? So that is a valid question. But if I see, I can apply here 5 volt to minus 5 volt only, or very small ranges, maybe minus 10 to 10. But whereas in rectifiers, suppose it is a rectifier, the input is from the AC voltages from our homes, so that is 230 volt, right? So we have to use a step down transformer here, something like this, which will convert this 230 volt to 18 volts or 9 volts, etc. If I take that 9 volts, etc., right, so then we can give it to the rectifier, then filter, capacitor, etc. So that will convert from AC to DC, right? So, and here we have some drawback, that is the capacitor is taking some time to charge up to 2 VM, or we can say the moment that we add some capacitances, transients will come, right? So whereas in first we use a rectifier, then it will convert from AC to pulsating DC. Then if I add the capacitor filter, so we'll get approximate DC, but there is some ripples will be there. Then if we add voltage regulator, we'll get perfect DC voltage, right? Something like this. So that's why when I want to convert AC to DC, we have to use this circuit only: rectifier, then filter, then voltage regulator, etc. So these circuits will be used some other applications where the diode are working very high voltages, maybe 200 volts, 100 volts, right? I'm having suppose 10 volt peak to peak or 100 volt peak to peak, but I need 200 volt DC. So in those cases we may use these circuits, that is voltage doublers or triplers and so on, right? Now we'll discuss voltage tripler and quadrupler. The same circuit will give the tripler and quadrupler. That is, if I take the voltage or output across this as Vout1, it will give the tripler, and if I take output across these two capacitors plus minus Vout2, I will get quadrupler. That is, Vout2 will be 4 times of Vm and Vout1 will be 2 times of Vm, and so on. Now we'll see the analysis. Very simple. So we have to apply at least 4 half cycles, but if I go practically, so we have to apply so many cycles to charge up to 2 Vm, 3 Vm, and so on, right? So that you can verify by doing the simulation in LT-SPICE, right? Now if I apply the first positive half cycle, what will happen? So if I apply first positive half cycle, this will be plus minus Vm. Now see, I can apply directly the analysis. Plus will be connected to the positive terminal of the diode D1. So first positive half cycle D1 on. So here positive I am applying, so D2 will be off. Similarly, the capacitor is initially uncharged, so whatever we are applying here, that will be across here, across here, across here, and so on. So that means the diode D3 will also on because I am applying positive here. What happens to the diode D4 will be off. So D1 and D3 on, D2 and D4 off. Now the circuit will be like this. So maximum we can apply Vm, capacitor C1, so it will charge, so that is Vc1, this is the short circuit, and this is the open, this is the C2, and this is the C3, this is the short circuit, and this is the open, and there is the C4. So anyway, okay, there should be ground here. So the capacitor C1 will charge through this path. What is this voltage? 0 volt. As I know, shorts means. So this is, so the capacitor C3 will charge, because see, if you see this path, there is no voltage here. So C3 Vc3 will be 0. So only first half cycle the capacitor will charge it to how much? Minus Vm plus Vc1 equal to 0. So Vc1 is equal to Vm. This is the for the first positive half cycle. Then if I apply the first negative half cycle, so first negative half cycle, so what happens to the diode D1? Yeah, we already know. So when I apply negative half cycle, D1 will be off, this one will be on, anyway this will be off, this will be on. So see just terminals of the diodes, both are n type semiconductors which is connected to negative when I apply the negative half cycle. So that means D1 off, right, and D3 also will be off. So D2 and D4 will be on. So circuit will be like this. Maximum I can apply Vm. So this is already charged to Vc1, which is equal to Vm, and it is open circuit. This is the capacitor C2, and here the diode D2 will be on, so short circuit. So here C3, and this is the D2. So D3 here will be off. So this is the capacitor C4, and the D4 will be on, so short circuit, right? Now we have to see the polarities of the diodes. Now see, D2 polarities from P to N means the current will flow like this. So that means the current direction in this path is something like this. And what happens to the diode D4? Same, right? Now I can apply KVL in this slope to find the Vc2. So can I say this is plus minus Vc2? Now see, this is short circuit. What is the voltage? Will be 0. So capacitor C3 and C4 still uncharged. So if I apply KVL in this slope, so I'll start from Vc2. So Vc2 minus Vm is equal to 0. So what is Vc2 now? 2 Vm. This is already we know, right? 2 capacitors, so up to maximum 2 Vm only. So this is up to first cycle, that is first positive half cycle and first negative half cycle. Then if I apply next positive half cycle, so that is we can say second positive half cycle. So how much I can apply? Maximum again Vm, and this is C1 which is charged to Vm, assuming that it is not discharged. Then what happens to the diode D1 and D2, D3, D4? So again I am applying the positive, so D1 will be on, positive, D3 will be on. So D1 and D3 on, D2 and D4 off. So on, short circuit, right? So this is C2, which was charged to 2 VM. Already we know this is open. This is C3 and this is short circuited. This is C4 and it is open circuited. Now see, now the capacitor will charge through this path. So see, the current direction is this. See, this is the D3. So now if I apply KVL in this loop, so this will become minus 2 VM plus minus, I am assuming VC3. So VC3 is equal to 0. So what is VC3? 2 VM. This is the polarities, right? So this is up to second positive half cycle. So one more, second negative half cycle. Again the same scenario, D1 and D3 off, D2 and D4 on. So the maximum I can apply how much? Minus VM. So minus plus VM. The capacitor C1 charged to VM. This will be open. And this is C2, which is charged to 2 VM. And here D2 on. This is the C3, which is charged to 2 VM. So this will be open. And this is the C4. And this is the short circuit. And tell me what is the current direction in D4? Something like this. Now if I apply KVL in this loop, I can get plus minus VC4. So minus 2 VM plus VC4 is equal to 0. So what is the VC4? 2 times of VM. So we got VC4 as 2 VM, VC3 as 2 VM, VC2 as 2 VM, VC1 as VM only. So if I see the circuit, the initial circuit, after this second negative half cycle, this is VM, this is 2 VM, this is also 2 VM, this is also 2 VM. So if I take the output across these two capacitors, so apply KVL. Minus Vout 2 plus 2 VM plus 2 VM is equal to 0. So what will be the Vout 2? 4 times of VM. Similarly, if I apply KVL in this loop, so we will get minus 2 VM minus VM plus Vout 1 is equal to 0. So what will be the Vout 1? 3 times of VM, right? So that's what is called voltage tripler. If I take output across C1 and C3, and it is called voltage quadrupler if I take output across C2 and C4. So this is the operation of voltage tripler and quadrupler, right? So I hope it is clear, the voltage doubler, tripler and quadrupler. If you are having any doubt, please post a comment.